Well, so hello. This is going to be a session about mobile testing, but we're going to cover some of the generic concepts of testing. We will be writing some code. Actually, I will be writing it, but if you have your laptops with you and you have Android Studio, you're welcome to do that. I do the same stuff with iOS. So still, if you feel that you can translate from Kotlin on the fly to Swift, you're welcome to do it and ask because I know how to do that too, okay? So my name is Jorge. I know it sounds difficult to pronounce, but I think you use an X for the sound here, and you have a similar sound here. So you're more than welcome to do any questions while I'm doing the presentation. The name of the presentation is the 7 stages of unit testing. And what I'm going to cover, as I said, is different topics with different levels of complexity about unit testing in the mobile world, okay? So let's start with the agenda. And in order to do that, well, first, привет, because I think that's the appropriate word here. And what I plan to do is, I know that I'm preaching to the choir here, but very likely you are already convinced that you should write unit tests. Otherwise, it wouldn't make a lot of sense to be here. But believe it or not, in many companies, in many mobile development companies, they don't believe that. So part of it is what you should tell your colleagues if they don't believe that this is what they should do. But then we will do the actual testing. I mean, I don't think it makes any sense to sell that you should be doing that without actually doing some stuff so people can have the knowledge to write that code. And, well, the presentation is written in the way that you would feel, I don't know if you know this theory about grief. I mean, if somebody that is close to you dies, how would you feel, the 7 stages that you go through? But instead of that sad event, we're going to talk about something happy, which is writing unit tests, how people feel about writing unit tests. And in the first stage, when you tell them, hey, you should write unit tests, most of them are like, me? Should I write unit tests? I mean, like, come on. I mean, like, are you telling me? My code is awesome. Why should I write my code twice? It makes no sense. I write it right the first time. Why should I write it again? If my code is written properly, I don't need to write another version of the code that checks that I am doing a proper job. So the idea here is not to try to be rude, but I know that if you're here, you're the kind of person who already knows how to do this code. So let's be selfish for a minute. Let's worry about ourselves instead of worrying about the others. And these are the things that you will get as benefits for writing good tests. All these ugly discussions that you have with your colleagues, this is not working, this is not working as expected, or you should do this in another way, you don't have to worry about that because the proof is already written there. So I don't have to argue with my colleagues at work saying how this works or whether it works or not, because it is already proven. The second thing is explaining. It's boring to explain people how code works. So instead of having all these assumptions that are somewhere in your head, they are written in the test. So when you pass the test to somebody else, the assumptions are written there, and they will read the assumption. This works only for these values. It requires this parameter to be passed, or any other. These questions, I don't know, I mean, again, I was having a very brief conversation before we started with Andrew, and I don't know how active the scene is here in Moscow. It's my first time here, beautiful city, beautiful people, but so far I don't have enough experience to make a judgment about the scene, how fast companies are hiring people, how much activity is in the market. I believe it is high, but I'm not sure about that. But in many places, it is the question that you have very often new people brought to the company. And if that is the case, you have to tell these people how things are, and you get these ugly questions about why did you do it like this instead of like that? What do I do in order to change this? So you don't need those questions. The documentation is already written in the code too. Not only the assumptions, but how it works is written in the code. I know that if you write code and you're here, you are not the person who writes code and introduces bug. We are cool people. There are some others in our organization that make mistakes, not us, okay? So these people who make the mistakes all the time, they will probably change the code, and it will affect to your code in a way. The way to figure out that they are the ones to blame and not you is because you have the test. So when they introduce a test, it is easy to let them refactor without affecting the code that you wrote, okay? One thing that I don't know if everybody has the same feeling about that. It is very common for me to work late at night. I'm a freelancer. I work for companies, I do training, I do consulting for companies. People hire me to help them to improve their architectures or to put best practices in place. So I go there, I take a look at their applications and to their code base, and I try to point out how to improve it and what are the things that should be improved first and so on. But it is very common for me to create code basically for my trainings or for my customers late at night. So when you are doing this, missing deadlines is easier because it's work at night, but you also work during the day, a lot of work, and what you have is a better estimation of your time schedule. What I mean by that is, when you write unit tests, it looks like you are doing more work, at least initially. And don't get me wrong, I'm not saying that writing tests requires no work. What I'm saying instead is that if you write unit tests, you catch some errors sooner than later. So the time you spend writing, fixing these bugs in the debugger is reduced. I don't know how good you are about debugging, but my feeling is that when I'm trying to debug, I get in the debugger, but I don't know how long it will take me to fix a bug. Sometimes I have the feeling that, oh, this is going to be easy. I'm going to spend 5 minutes and I'm going to solve it. 2 hours later, I'm still in front of the computer saying, this was going to be easy, but it's not, okay? So I don't know why, but it took me longer than expected. While if I catch this error early because I have the proper test in place, then I don't have to spend all this time debugging. And finally, when you have to do all this work later, well, a lot of the code that you get is reusable because now you have tests in place, and if you move it to some other project, it is easy to understand how it is affected by the other project and how it is reusable because it is tested, okay? So being selfish, like worrying about yourself, means that you do test, okay? The biggest advantage of writing unit tests for your project is that while you are writing some code, you are testing that code, even manually. Like you check that you write this method, the output of that method is this value, you write this other method, and you are trying to check that everything goes smoothly. But let's be honest, the next day, you are into something else, and you don't test the part that you wrote yesterday anymore. That part is written, and it was working properly yesterday. If you do any change that affects the code that you wrote yesterday, then you don't notice because you are only testing the code that you're writing today. So if you have automated tests added, then you are checking everything all the time. So every new change that you do to your code will be verified against the new changes that you introduce in them. Okay? So, yeah. And mostly you are focused on the public interface, so not the details of implementation. How to get there, which is, like in many companies that I go to do consulting is, well, we understand that we need to improve the quality of our code. In order to do that, we understand that we need to put unit testing and acceptance testing and integration testing in place. But we have none. We haven't, or at least we have only a few. So how do we make progress in order to get these unit tests in place? Well, the idea here is that you don't have to have full coverage. That's best scenario, but if you don't have it, it's okay. You can still look at the face of your colleagues and don't be ashamed, okay? So the goal here is to progressively improve the coverage of testing that you have in your code base. And in order to do that, you will notice, very likely, that sometimes it is very hard to introduce new tests in your code. If it is the case, then you should apply the solid principles. Are you aware of the solid principles here? Yes? Only 2 hands? The rest of you have never heard about those? Let me tell you the name of the solid principles so it might ring a bell. The first one is very commonly known because it is the single responsibility principle. Have you heard about that? Like an object should do one thing and one thing only. Actually, the principle is an object should only have one reason to change, but most commonly is like you do objects that do one thing. If you need another thing to be done, you create another object. So that is easier to test because there's one implication in that test, and that's it. The other 3, 4, I will mention it just by name, but this is the open-close principle, the Lysakov principle, the interface segregation principle, and the dependency inversion principle. And if you don't know them and want to know them, ask me afterwards, and I will explain each one of them if you want to. The easier way to start getting some coverage in your project is by introducing a test every time you are told about a new bug. So you get a new bug report, and instead of I know that the temptation is, oh, let's fix it. But instead of writing the code to fix that, you go and introduce a test that obviously will not pass because the code is broken in that aspect. Then you fix that, and the test magically passes. The advantage of doing that, I know that it sounds stupid because anyway you're going to fix it. The advantage of doing that is all these regressions that you may have in your code disappear suddenly. Why? Because now I have tested that this works properly. But next day, my colleague, the next table, is going to fix some code, and it may affect the code that was there and reverse the change that was done by me. But then the test will ring and it will say, hey, you are changing something and it's breaking the code that we fixed. If you don't have that test in place, you will never notice. It will be going back to the previous situation, you will have the bug reintroduced in your code, and you will never notice that this is what's happening. So let's go with stage number 2. And by stage number 2, I mean denial. People start thinking, well, okay, I understand what you're saying about unit testing, but it takes forever to write this test. And I want to be productive. I have some goals that there's some code that I have to deliver. I have to have this code in time. So in order to do that, I don't want to spend my time writing tests. So how do we do that? Well, the first thing that you have to take into account is what I mentioned before. The time it takes to write new tests is usually less than the time it takes to debug the problems that you're introducing by not having those tests. But the good and the bad news about testing. Well, all the things you need to do in your code are already there. There's no additional tool that is required in order to add unit tests to your mobile application. Android Studio provides with all the tools that are required in order to be productive in terms of writing unit tests. The projects are already created with a source set for testing, actually with 2. One for instrumentation testing and another one for unit testing, which is perfect. One can be used for acceptance and the other one can be used for unit testing. Awesome, we have everything we need there. The example that is there, quite crappy, totally useless. But still, we have all the tools there. If you're doing this properly, you never go and click on the IDE in the play button to say, run my test. This is not you. If you do that, you should be ashamed, but I know you don't do that. What you do is you use a shortcut to run the test, and you have muscle memory. So every time you're writing at some code, you immediately, like your body moves to write the test, to run the test again. It goes smoothly through your arm, okay? So it's like, and I think the guy is well known here, Ivan Pavlov. Does it ring a bell? I think he was Russian. So Ivan Pavlov was famous for teaching dogs when they were going to eat by ringing a bell, and their behavior was reinforced by the bell. So you can use voices in your IDE saying, this is going smoothly when the test passes. And another voice saying, hey, you better work more if it doesn't. So you have some kind of Pavlov reinforcement there. The tool that you need for that is JUnit. Some other people like other tools, and I'm not going to have any discussion about whether spec is better than JUnit or not. I like all of them. I don't have any particular hard feelings against any of them. But if you just want to go with the basics and don't overcomplicate things, JUnit is there, and you have everything that you need. The other things that you can add are the mocking frameworks, Mockito and Mockito Coding, which in this case would be required if you want to do more advanced testing. But initially, with JUnit, you can run a very long trip by just using this tool. Let's go with stage number 3. Anger. And the question here is, how do I write these freaking tests, okay? And I said freaking, okay? The question can be answered in many ways, but the ideas that you have to have as a goal when you're writing unit tests is, don't ever, and I mean that, ever, write unit tests for code that you didn't write. So usually we feel tempted to test some library that it writes the data and we get the data back. No, you didn't write let's say that you're using Realm or Room or anything like that. You don't want your test to verify that Room behaves as expected, or Realm behaves as expected, or your API in your server behaves as expected. That's not the goal. What you want to test is that you communicate with these APIs properly. That's it, not the other way around. The only good reason that you may have to run a test, to create a test for code that you didn't write, is when that code seems to be broken and you want to prove it to somebody else. If you want to send Google a report saying, hey, you claim that this is what your code does, but I have found otherwise. I have found that it doesn't behave as expected. And then you want to prove it to them so they can fix it. That is the only good reason to write a unit test for code that wasn't your own. Only one level of abstraction. And by level of abstraction, I don't know, let me ask you. How many here have kids? Kids, yeah, okay? Only a few. But nephews or similar. Have you ever been a kid? Yeah, okay. So if you know how young kids tell stories, and I assume that's universal, when you ask them about a movie, they start talking about very high-level details and very low-level details. So the princess was beautiful and had blue shoes, which is totally irrelevant to the rest of the story, okay? If you write your code this way, that's dangerous because it makes the code less readable. So usually what you have to do is to create your code in a way that it will be at one level of abstraction, and that is the top level that you are trying to test. Usually, the rest of it is private. They are implementation details. You don't care about the implementation details when you are testing. But most likely because these implementation details will change later. And if they change, you don't want your test to be broken because of these changes. What you want to prove is that the general behavior is what is expected. So, only public methods in order to do that. The implementation details are hidden. And in general, and notice that I put a star here, which means maybe, only one assertion per method, okay? And it has pros and cons, and I can comment that when we write some tests, but only one assertion per method. Finally, and this is a goal, and Android Studio helps a little bit more than Xcode here, your test should not depend on previous states. I mean, like, if you run the test in any order, it should give you the same results. It is very disappointing to write a test once and see that something fails, run it again, and see that it passes. It's like, maybe it works, maybe it doesn't. No, I don't want that. I want it to either fail or pass. But not this is not Schrodinger's behavior. I mean, like, this is not putting a cat in a box and putting it with some poison, and the cat is both alive and dead. No, 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 no. Your code has to be alive or dead, but it cannot be anything in the middle, okay? So, without any further ado, what I'm going to do is to explain with code these three kind of tests, which are the three kind of tests that you usually do when you write tests for object-oriented code. If you're running functional code, you will be laughing at the middle one, okay? It makes no sense. I mean, like, having the behavior tested, the state tested makes no sense, because the purpose of functional programming is that you don't store a state anywhere. Let's start with the return value. And what I'm going to do is, well, let me first ask you, is anybody going to type with me, or am I alone at this? I'm a lonely cowboy? Okay, that's fine. So I'm not going to create the project since you are already watching at what I'm doing. And instead, what I'm trying to do is, this is a project that I have just created before coming here. It was created in the speaker's room. And is it readable? Can you read it? No? Let me try to find another. So it's just a matter of color. Let me check then a theme that it is more readable, okay? So here we go. No, come on. Kidding? So everything is dark, but is it more readable now, at least? Okay, sorry about that. I hope, if you cannot read it, just let me know and I will try to make it faster. Okay, so this is a project that is created by default. There's no code in it. I mean, like, only the template for a project in Android Studio. What I'm going to do is create the first piece of code, and then I will write the test for it. This is not TDD, which is the other way around. We would write the unit test before and then the code. Not this case. We're going to start with the code. I don't know how it goes here in Russia, but in the part of the world that I live in, you get far more money, more success if you work for the bad people. So this is going to be a theme park for evil people, okay? And we are going to start by creating a single class that is going to be, let me create a group here. I'm going to call this group model. And inside of the model, I'm going to create a new class that I'm going to call supervillain. Okay. This supervillain is like any other evil person. It has a name, which is a first name and a last name. So let's reflect that in our object. So we're going to say data class, and what the name is supervillain. And in Kotlin, you can define the constructor right at the beginning and say, I have two variables. One is the first name, and it's going to be a string. And the second one is also a variable, and is the last name. and it's going to be a string. So far, so good? Okay. If this is my object, one very useful property, computed property, is to have the full name. I know this is not universal, what I'm going to do now, but for the sake of the example that I'm going to do here, let's assume that first name concatenated with a space and the last name is the full name of the person. It doesn't work with my name. I have two last names. In Spain, we have two. We're this good. I mean, like, so the property that I'm going to have here is called full name. And what I'm going to do is to just return the first name, space, the last name. So far, so good? What I would like to test now is that this, which is a computer property, but is exactly the same as any other method in your object, behaves as expected. Okay? This is what we are going to do in order to verify the code. Okay? So the code is here. Let's go and let's create, let's create a new test for this. And as you see, the IDE is already providing me with help to do that. I'm only going to use that is JUnit4, and that is a supervillain test, the name of the class. That's it. I'm not going to create any of the boilerplate here. I'm going to do that manually. It has the only difference here, and that you have to take into account, it offers you two options in order to choose where to put this file. The Android test 1 is the one that is meant for instrumentation testing, mostly for the acceptance testing, like tapping on a view and seeing the behavior there. While this test, only test instead of Android test, is meant for unit tests. So if you do that, the only thing that you have to take into account that the code that we're going to write now is in test, not in Android test, okay? We have the class, so let's start by creating the body for the class, and let's write the first unit test. The first unit test is going to be a JUnit4 test, and the name of the test, I used to be an Objective-C developer. I don't know if you have ever written any Objective-C, but names of methods in Objective-C are not long, not very long, but very, very long, okay? So I'm not ashamed of writing long names. That's how I learned to do things. So in order to have a good test, the name of the test should be telling. Why? Because when you see that it doesn't pass, you want to know what has gone wrong. Instead of trying to go to the test and read what is going wrong. You just want the name of the test telling you, hey, this is what you did wrong, fix it. You don't have to spend any extra time going back to the problem, okay? So let's be explicit. And what we are going to do here is full name is first name, space, last name. And look at me, I'm not ashamed, okay? You can do it too. So I don't know if I wrote it properly. Okay, perfect. So what I have here now is the skeleton for a test. But since we are learning how to do this, let me be more explicit. If you write a good unit test, it usually has 3 steps. The 3 steps are, there are different namings for this. I use the 3 A's because I use batteries. Do you do batteries use the 3 A's here in Russia? Yeah, so it's easy to remember 3 A's, okay? And there is the given, when, then, that people usually remember, that is more BDD oriented. In the unit test world, I think it's easy to remember the arrange, like prepare everything, act, exercise the method that you want to test, and then assert. Say what you expect. And if it's not there, it will fail. Okay? So far, so good? So let's go and let's write the first unit test. The first unit test is going to arrange things, exercise the method, and then we will assert what we expect. Let's go step by step. In the first step, we're going to create, an instance of the object that I'm going to have. Notice that I have called this SUT. This goes for system under test, the thing that I'm testing, okay? So because this is a unit test, usually we're testing things in isolation, and in order to test that, this SUT that I'm testing here is pretty clear because I have only created one object, is the supervillain, okay? So the supervillain is what I have to test here. Let me make it clean. And in order to create it, I have to provide the two values that I define in the constructor. So first name is going to be Lex Luthor. You know who Lex Luthor is? The bad guy of Superman. Superman, yeah. So Lex. And the last name is Luthor. So we have a supervillain that is ready to behave for us. This is the arranged part. Now we're going to exercise the code that we want to test. What is the code that we want to test? Full name. So this is what we're going to get. So we create a variable, well, in this case a constant, that is going to be called full name. Well, that is going to be the result of invoking the full name of the SUT. So far, so good? Is it clear? Let me try to move this a little bit upward so everybody can read. So far, so good? Yeah? The last part is the important part here because this is where I check that everything went smoothly, okay? So what I'm going to say here is assert equals. I'm going to say these two things are equal. And the first thing that I'm going to say is the expected value. The expected value is going to be Lex Luthor. So far, so good? And where I want to have this value is in the property that I declare up there, which is full name. Does it ring a bell? Does it make sense at all? So, I know that this is scary, but let's run it, okay? First time, you are allowed to use the play button. Afterwards, no play button, okay? So, I'm running this. It's showing me here the one that came with the project and the other one that is a supervillain test. Notice that if I expand this one, the name of the test that I wrote is green, meaning that, hey, everything went fine. And if I had more tests here, I will have them under supervillain tests if they are inside of this class, okay? I'm a little bit picky, so I'm going to get rid of the other guy, this one. Sorry, but bye-bye. I'm going to Dos Vidania, is that how you say that? So Dos Vidania, let's delete that one, okay. And if I run it again, now with the keys, you will see that it shows up here properly, and it's telling me that everything is green. You want to be green. Even if it's not your favorite color, but you want to be green. You want the green. This has to be a greener world. We're looking for no climatic change and so on, so green is better. Okay, let's go with the second one. In the second one, we are going to test for state, okay? So as you know, in object-oriented programming, when you have code, when you have a class, it is very common, not necessary, but very common to store things in these objects. They are usually accessed via properties, but you have some kind of internal storage to have a state in that object, okay? In our case, the state is obtained by the properties first name and last name. So let's go and write the code here. And what we're going to do here is to go back to the supervillain and And these are the two properties that we want to change. And what we are going to do is to get the opposite effect. If I give you a full name, you will change the first name and last name in your code. Okay, so how do we do that? Well, the first thing that we need to do is to make this property read and write, because so far it is only a read property. I'm going to define that the getter for this property is what I had before. And the setter is what I'm going to define now. Here I'm going to get whatever I use in the setter of the full name. So if I get a call to supervillain.fullname equals whatever is going to be in value, okay? So what I'm going to do is, with this string, I'm going to split it using the spaces, and then I'm going to put the first part in the first name and the last part in the last name. I know that this will break in so many ways that it's amazing how bad this code is going to be. So forgive me about that. I'm going to do just the first iteration of this. Obviously, if you're writing this properly, you will need to do a lot of checking. Does it have one word or many? If it doesn't have any, what do I do? Take decisions on that. If it has more than 3 words, what do I do with the words in the middle? Or do I take the first and the second and ignore the rest? All these kind of decisions that we are not going to take here, okay? So what I'm going to do in this method is say val components, var components, meaning the components of the name, is going to be the value split with spaces. Okay? And what I'm going to do is first name then is going to be components first, and last name is going to be components second. It's funny that we, as computer science geeks, write second and type 1. But, okay, let's go with that. So the code is written. Now I would like to test that this code works as expected. Okay, so let's go back to the test. And here I'm going to write a second test. Anybody wants to help me with the name? Don't be ashamed. Come on, a good name. What? No, come on, a good name for the test. Not for the evil guy, which I think is what you were thinking, and I will use that one. But for the name of the test that we want to check. What? So what we want to do here is set full name, and that will set first and last name. Is that right, more or less? So full name sets first and last name. Is it readable? Is it understandable what we're expecting there? I mean, don't get me wrong. I have 3 daughters because I want to choose names, but after that, everybody has different wishes, different tastes on how to name things. What I'm saying is, it has to be obvious what you are executing here and what you expect. If it is not obvious, then you are doing something wrong, okay? So, let's go step by step. We're going to create an instance, and hey, I'm Spanish, so I'm lazy. Let's go and copy the other one, okay? Don't tell anybody. If you go and talk to your friends who have gone to the good talks now, you don't tell them this part, okay? Has happened. We have created one instance of an object. The second part is exercising the method that we want to test. So in this case, it will be suit dot full name equals, and what was the name of the evil person that you had in mind? Mary Poppins. Is that evil here? Sometimes, okay. So Mary Poppins. Is that right? I don't know if this is the right spelling. I hope so. And what do we want to verify here? Well, we have to verify two things. Do you remember that I said only one? I was cheating. So two things. The first thing that we want to verify is that Mary is Suit's first name. The second, and I know you have that in your brains already, is that Poppins is Suit's last name. Is this more or less what you had in mind? So range, act, exercise the method that we're testing, and assert. In this case, we do two assertions because both of them point to the same part of the code in order to fix it. If one or the other is broken, our code is broken, and we want to know. But that's why we want to have two assertions here, okay? So how is it going to Control R and come on, I know that it's right after lunch, but some emotion, some feeling here. Okay, I will try again with the third one. Let's try with test behavior. And if you ask me, when you are writing code, I would say that 10% of your test could be returned. This is an estimation, digital estimation. Yeah, please go ahead. Oh, yeah, that's an excellent question. Let me point out that. So his question was, how is the test that we wrote different from the value? Well, and I'm sorry, I missed saying that, so thank you for your question. Notice that in line 34, I'm getting the result of calling the method. So this is the return value. The full name is what it's returned by this method. However, in this case, full name doesn't return anything. What it changes is the state of the actual object. What I'm verifying here is not what has been returned here, because nothing has been returned, but rather what was set in the object. You see the difference? It's a little bit tricky, but what you're checking is the state of the object rather than what a method of the object has returned. Okay? So I would say that 10% of the tests that we write are return tests. 20, again, digital estimation, okay? 20 would be state, and the vast majority of them would be behavior. So if you have to pay, if you were sleeping till now and nobody noticed, you wake up now because this is the more important part for testing, okay? And what we are going to do is to write the final test here, the behavior one, which is the interaction with other objects. And it is very common in the code that we write that our code interacts with other objects of our application. So that's why it's so important. Let's write the code first, and let's go with what it can do, and you will see how come it is so frequent to do this. As I said at the beginning, this is going to be a theme park for evil people. What evil people do love doing? They love attacking. And in order to attack people, they want to have a mega weapon, and they want to fire the mega weapon. They are really bad people, even Mary Poppins. So what we're going to do is we're going to define an interface for a weapon, a mega weapon, like this big, okay? And this mega weapon is going to be a new class here. So, sorry, not a new class, but a new interface. Oh, no. Call it. And this is going to be mega weapon, and let's do this properly. It's going to be an interface. So what I'm going to have here is an interface that is called mega weapon. And this defines, in an abstract way, anything that can be considered a mega weapon. So what do weapons do? They have a method to fire, okay? So we will say fire is a method that a weapon has. Let's do this properly in coding instead of in Jorge's, because this is what we're expecting to have here. So we define a method that says, if I run this method, I expect the weapon to fire, okay? So now I'm going to use this mega weapon that I haven't defined any object, any actual weapon, but I know how a weapon should behave. I'm going to use that in the supervillain. I'm going to define a new method that is going to be called, fun, attack, and it takes a parameter, weapon, and it does, the type of the parameter is a mega weapon. So far, so good? Any questions? No? When we have that weapon, where's the next thing that we do? If we are the supervillain and we are attacking, the thing that we want to do is we fire the weapon. So we use the weapon, and we fire that thing. We don't know what it is, but hey, it has a trigger, we fire it, okay? And this is the code that we want to write, and this is the code that we want to test. Okay, so let's go and let's try to write the unit test for that. Let's create a new test, and attack fires mega weapon. Okay? So when I attack, I expect the weapon to be fired. Okay? Perfect. Help me here, and I need a lot of help. First thing that we want to do is create an instance of the supervillain. Nothing new. I hope. I mean, like, this is what we did before. Second thing that we want to do is exercise the method that we are going to test, which in this case is going to be, what is the name of the method that we want to test? Attack. Thank you. So suit.attack. Okay? And here comes the problem. So I want to assert, what do I assert? I mean, like, well, assert, I assert that the suit has attack? No, that was what I did, so I know that. How do I assert that the thing that I was expecting to be fired was fired? Well, notice that it is complaining here because I didn't pass a weapon. So let's do that. Let's create a weapon, and we don't have any weapon. We have to create some fake weapon in order to do that. What we're going to do now is, hey, we don't trust our supervillains because they are bad people. So instead of giving them a real gun or a real weapon, what you do is you give them a fake one. Okay? You give them a fake one, and they get the weapon, and obviously it's their feeling. So they push the trigger, and in order to do that, we want to record when the trigger has been pushed. So what we want is that this fake weapon records in a way that the trigger has been pulled. That is the behavior that we're expecting to measure here. So let's do that. Let's create another class. This is going to be an internal class in the unit test class that we're writing. And we're going to call this class weapon, mega weapon double, meaning that it's not the real one, it's a fake one, okay? And what I'm going to have is that this mega weapon double is going to implement the mega weapon protocol. Because we want something that we can pass on to the attack method. So in order to implement the protocol, we just say, hey, let me see if I can make it work. Okay, so it creates the skeleton for me, and it says, hey, I'm implementing the fire method. What do I want the fire method to do? I want it to remember when the trigger was pulled. So I can say something like, var was fired, and say that this is false initially. And when something happens, and by something I mean it gets fired, then I say was fired equals true. So we have a new class that is a fake thing that behaves as a weapon, and that it will remember whether it has been fired or not. Now, the only thing that we need to do is in the arrange part, we create an instance of this class. So weapon equals mega weapon double. And when we have that instance, we pass it on to the weapon that is used for the attack. And the assert, we can say assert true that weapon was fired. Is it beautiful? Like, don't you feel better now? So, Control R, we run it, and we get 3 tests, the 3 of them running. No? Okay. So, that was for, please, go ahead. No. I mean, like, the goal here is not check whether the weapon class behaves in a way or another. The goal here is check whether if a supervillain gets something that speaks the mega weapon protocol, or interface, rather, it will use it to trigger it, to fire it. We're writing the other part. Again, sorry?
We override this function, which already became other way.
Yeah.
This function is like different now, because we override.
So, I see your point. Let me make it public so everybody can hear what you said. So, the idea here is, what his point is, I'm not using a real weapon. I'm using my version of a mega weapon with a method that is written as I wish it to be. But the purpose is not testing what happens in the method of the weapon. What I'm trying to test is that the supervillain is going to use that method. Whatever happens in that method, I don't care. What I want to test is that what I have in the code, and let me show you the code for a moment now. What I have in the code, wow, we have music. So what I have in the code here is I want to verify that if I pass a weapon, it doesn't matter what weapon it is. It could be a bazooka, or it could be a very tiny gun, okay? Doesn't matter, but as long as it follows the fire method, so it follows the mega weapon protocol interface, I use it to fire. It can be any implementation. I'm not worrying about the implementation of this. What this will trigger, I mean, like what will happen as a result of this being called, I don't know. What I want to be sure is that it triggers that behavior. Let me put you a different scenario. So the thing is, imagine that in order to do, you want to verify some network API, for example, okay? And what I want to verify is not how the communication goes from my application to the backend. No. What I want to verify is that I invoke the right methods with the right parameters of my API in order to keep this communication with the backend. That is what I'm testing, not the communication with the backend. You see the difference? The difference here is, yes, the communication could be implemented in many ways. What I'm interested about is that this behavior is started, that is triggered. After that, it will do one thing or another, and I will have to test the other object to verify that it does exactly what I'm expecting to do. So here, I'm only doing partial testing. I don't have any actual implementation of Mega Weapon, so I haven't tested what this method will do in Mega Weapon. I will test it later. I'm not going to cover this in this session, but the goal here is if you're writing the full application, you will want to verify that this triggers the expected behavior. But what you want to test from the perspective of the supervillain is that it talks to other objects in order to ask them to do whatever you want to do. Is it clear? Thank you. So let's go back to the presentation. And this is the bargain phase. I hope that by this time you see that writing tests is not that difficult. Very expressive, I mean, like 3 steps. We create the things, prepare them, we execute the thing that we want to test, and then we verify the behavior that we're expecting. That's it. There's nothing else that has to be done there. But when you are doing this for a while, it's like, wow, but this is really complicated because every time I have to interact with, I told you already, 70%, again, estimation, of the tests that I'm going to write are going to interact, are going to test behavior with other objects. So do I have to create all these objects all the time in order to do these, create fake objects that behave as expected? Well, no, you don't have to because there are frameworks that can help you to do that. So let me show you a little bit of that. And one particular thing is how you apply this to your architecture. And I don't know if this sounds really challenging. What I'm going to cover here is more generic. I'm not going to do any example. But if you feel that this is challenging, we can start by creating a very small example. And I will need your help to do that. The thing that is helpful is that when people start writing tests, they start with a model. The model is usually pretty easy to understand. Let's say that you are talking about taxis, like Get's business model. I know where a car is. I know where, like the ride that is going to perform. I know that the driver has all these points. I know all these things are easy to test, okay? But when you are writing an application, there's more than that for the application. You also need to have some views in order to show this information to the user. And you want to show that you want to verify that if the user taps on any control in the view, your application is going to behave as expected. You want to verify that you are triggering the right methods in your logic in order to respond to that behavior of the user. So that is what is usually very, very challenging, at least at the beginning. When you're writing the first testing for your application as a full, that's the part that usually people is very afraid of starting. So let me soften this a little bit. I know that it's going to be painful, but it's not going to be that painful, okay? I need some hands up, okay? So, do you use Model View Controller, or have you been told about Model View Controller in your applications? Hands up, 2, 3, no? Model View Presenters, nobody? 1. Model View Models, no? Wow. So this is going to be a long talk. You know this talk about bees and flowers? This is not the talk. Different thing. So what we're going to cover here is how you organize your architecture. And obviously, I told you at the beginning that I do trainings for companies and I have them also doing consultancy to fix their architectures. So usually, when I'm teaching them, the beginning of it is like a week. Less than a week, I cannot do anything that is meaningful. Well, 3 days is like the bare minimum in order to get something that is meaningful for people. So don't expect to get out of this session and say, hey, I'm an architect. No, okay? What I'm going to discuss here is how to do a basic thing, a thing that is very useful for your applications, which is how to separate the visual part of your application from the logical part of it. Usually, whatever you have in your domain knowledge, the business logic of your application, is something that is, as I said before, easy to test. But what you want to do is to separate the coupling, the connection between the UI and the logic, so you can test them separately. Okay? And this is how it should work. So, in order to do this, we have a model that it will hold all the data pieces. I mean, like, for the example of our sponsors here, this will be Gets. It may have drivers, it may have cars, rides. I don't know a lot about their model, but the usual things that you think about when you consider an application that is about hiring cars to go somewhere, okay? Payments, the points that you have as a user of the platform. And all these operations should be written in a way that if I change from platform to platform, it should be feasible. So it is just plain Kotlin code, Java code, Swift code. It doesn't matter the language that you use, but it doesn't have any relationship with the SDK that you're using. So if you're using Android, it has no Android SDK there. It is just Java or Kotlin code by itself. The visual part is provided by these two parts here, the view and the presenter. The view is the dumbest part. It is not very smart. It doesn't do much. It only passes all the events to the presenter, and it receives orders from the presenter in order to display things. That's it. So if I tell you that I'm using something like this, which is model view presenter, as you have guessed already, when you do model view presenter, the view doesn't know how to do anything. It is as stupid as possible. So what it does is whenever it feels that it has been tapped on some, by the way, this arrow is wrong. This arrow should be pointing only here. I have just realized that there's a mistake in the slide. So this goes here to send orders, and this goes backwards to send events. Let's say that I have an application that does very simple user interface. I have an entry for a name, and then I type my name, Jorge, and then I have another label down that when I press on a button, it displays, hello, Jorge, okay? Very stupid, very simple, but it has all the pieces that we need in order to do this. So let's try to figure out how this would work, and you will see how easy it is to test that. The view has a text field, a text view, a label, if you are in the iOS world, a text field, text label, edit text, text view, okay? And a button. Only these three elements, no more, okay? What are the messages, the events that the view has to tell the presenter? What? Okay, so if I tap on the button, the view who cannot do anything will tell the presenter, hey, the user has tapped on this button, okay? I agree with that one. Any other event that we want to know? What, sorry? The view is loaded. Perfect. I like that one. The initial loading of the view is another event that I want to share with the presenter, because then I can do things like, if the text field is empty, which usually is empty at the beginning, I can disable the button. The button can be disabled, so because I don't have any text there, the user cannot tap on the button without saying, hello. No, hello, nothing, it makes no sense. So I want to have some text there, so if text is there, I can say hello Jorge or hello whatever, okay? Okay, so I have two events here. Is there any other event that you would consider passing from the view to the presenter? No, it's okay. So let me restate what you said. So you were talking about keyboard events, more or less. So rather than keyboard events, since I have an edit text or a text field if you're talking about iOS, I would like to know when something is updated in my text field or in my edit text. Why? Because I want to have the latest version. Then I can do things like verifying that the name there has at least 2 letters. Because, yeah, I don't know. A name with 1 letter, maybe in Russian you have some of those. We don't have any in Spanish that are single letter names. But, okay, at least with 2 letters, I will allow it to be a name. So by having the latest version of the text, which is similar to what you were saying, I hope, I would know whether it is worth to do something on that, okay? So, perfect. I have 3 events. First event is the button has been tapped, which is the one that you told me. Second event is the view is ready, is already loaded. And third event is we have updated, the user has updated the content of the edit text. Perfect. Notice that in these events, the view doesn't take any decision at all. It doesn't. It just tells the presenter, hey, presenter, this is what is happening. What do you want to do? Okay? That's it. So, the presenter, which is the second guy here, is responsible for providing semantics on top of that. What I mean by that is that it will take the event and take a decision on what it has to happen as a result of that. For example, when I get the button has been tapped, I tell my model, do whatever with this message, with this name, and tell me, give me the result. So I can update it in the label. You see the behavior? Can I have 3 volunteers here? 3 volunteers. Come on. I've been told that Russian people is not shy. So I need 3 people. Come on. You can be 1, please. Give him a warm clap. Come on. Second volunteer. Second. And third volunteer. Come on. Third one. Shy people. Come on, please. Give them a warm clap. Thank you. So, let's make you... You want to be the view? Okay. You're the view. View. You will model. Okay. And you will be the presenter. You have 3 elements. Okay. I'm the user. Okay. You are the presenter and you are the model. You only have one method. That is, you receive a name and the method is greeting. So when you receive a name, you say hello, whatever. Okay. So the application starts. And I'm now getting the application loaded. What happens? Okay, now what do you do? She cannot take any decision by herself. If you don't mind, when you do say something for the record, so. So she told you that the application has been loaded, but she cannot take any decision. She is the view, and she only does pretty things. She shows people about the information, the user, the information that is available. So you know that the application is ready what do? Do you have a name to give him the name, to give Andrew the name so he can celebrate?
No, I don't have a name.
Do you have anything to tell her? Maybe disable the button because there's no name here?
Yes.
Okay, so tell her.
Disable the button.
And she doesn't take any decision by herself. What she does is take his order and say, I'm disabling. I have a method that will disable the button. So now your button is disabled. I'm the user now, and I start typing. What happens?
He's starting typing.
So
Something
every time
in my
I
text
change the text, she will send a new message to him saying, this is the latest version of the text. Okay? And you will have the latest version of the text. What do you do with that?
So I can give name to the
Notice
model.
that I'm the user. I'm the one saying when I finish with my name. I have just typed JO, and I haven't typed on any other thing. I haven't tapped on the button. So what do you do?
So I can check the name with some logic, maybe.
Okay, you check if the name is valid, and then if it is not valid, what do you tell her?
That the name is not valid.
What you have to tell her, she doesn't know about names. She knows about enabling or disabling the button. So if the name is valid, you tell her to?
Mark the name red or something.
For example, and enable the button. If it is not if it is valid, you will write it black, and the button will be enabled, and you will enable that. Now I have finished typing, okay? And I tap on the button.
The button is typed.
Okay, thank you. So the name is
The latest
Jorge.
version that I have typed, which will be Jorge. So Andrew, what do you do?
I'm giving back to presenter the name Hello, Jorge.
Okay.
So please show show hello Jorge.
So what you are telling her is display in the label this
Hello, Jorge.
the string, and you will display it to me. You see how this works? So now, in order to test her behavior, the only thing that I have to do is to give her a fake presenter. Not him. He is providing the intelligence behind that. What I'm going to provide you is with a method, a fake object that has all the methods, tab button, new message, whatever. And what I want to do is I run your view and I check that you invoke the right methods there. That's it. That's pretty easy. As for you, the only thing that I have to do is I don't need an actual view. That would be hard to test. The only thing that I have to give you is an abstraction of her behavior, so you can talk to her and say, hey, update this, but she's not going to be here. Neither is going to be Andrew. You're going to talk to a fake model and to a fake view. Testing yourself in isolation is easy. As for you, Andrew, you are totally independent of these guys. They can call you, you have a phone, you can be anywhere and answer, but you don't care about them. So testing each part of this application is pretty easy. You see? Is it clear? Any questions about how this works? No? Yes? Please.
What is MVP?
MVP is model, view, presenter.
One question. The model is not really dependent from the presenter because the data can be changed from the presenter to the model. So you have to emulate the presenter for the model as well.
I don't know if I fully understand the question. So you're saying that they are somehow coupled?
You told that model is independent from the presenter as the view, but in reality you have to emulate presenter for the model to... No?
Not really. I mean, like, what I'm doing with Andrew, if I were the presenter, or what he's doing with Andrew when he calls Andrew, is he has his phone call and knows that whenever he gives him a name, he has a method to say greet the name that I'm saying.
In this case, yes, when we only fetch the data, but when we change data, when it's working in the other direction, we have to emulate presenter.
I see your point. And so you're totally right. What I'm saying is, in this case, Andrew's behavior is given immediately. So when he is answering, he's providing with an answer to him as a presenter in a way that is independent on who the presenter is. He gets a call, he answers, that's it. There is another way that it can happen. So it could be that he's doing synchronization in the back end, for example. Okay? So he could be getting information from the back end. He's a very smart guy. He goes around, takes information from the back end, and tries to synchronize himself. He has asked for that, but he doesn't know about that anymore because he's doing some other stuff. So when he has the new data, what he will do is to say, hey, I have new data available. How do I do this in a way that is independent from the presenter? Through observation. What I mean by that is he will be implementing an abstraction, a method, that when Andrew has new data, it doesn't matter who he is. It could be him or it could be any of you. As long as he implements a method saying, I have new data, what do you do with that? Andrew will call saying, I have new data, and he will be notified of that. Andrew will not know anything about him. He doesn't even know his picture or any information about who he is. What he knows is that he has that method, and that's the only thing that is relevant for him. That is observation. It can be done in many ways. You can use reactive code in order to use that. You can use plain observation, or you can use features or things like that in order to provide this later behavior. But the important thing is that it doesn't matter how you do it, the way you write the code for the model has to be totally independent from the way you write the code for the other two. This model cannot know anything about the presenter or the view. Particularly, it cannot know anything about the UI. Because if it does, then it will be coupled to the SDK. The goal here would be that if we want to use Andrew for an application in the desktop, we still will have his code, and it will be completely useful to us to create an application for the desktop. Not only that, if we want to run it for the watch or for the Android TV, or if you're in the iOS for the Apple Watch or for Apple TV or whatever, his work should be suitable for all of these platforms. These two parts will have to be rewritten. Particularly, the part that you will rewrite more often is her part, because she is completely dependent on the SDK that you're using for the platform.
Yeah, I got it. Thank you.
My pleasure. So thank you. Give him a word. Thank you, because they deserve it. I think it was smooth. Have you ever been a view before? No? Have you ever been a presenter model? So, fifth phase, guilt. And you might be wondering, why is there guilt here? The problem is that you should be aware of what a test double is. And a test double, we have already mentioned what a weapon double was, but a test double is anything that is helpful to us to write good tests. And there are a few of them. I wrote the mega weapon double, but there are a few that you should take in consideration when you write tests. The reason why we use doubles nowadays is because there were two TDD schools. The London school and the Detroit school. That's Ken Beck, Rick and Bell here. Anybody knows Ken Beck? Extreme Programming, no? Well, very good books. I recommend you to read them if you haven't. He's a very smart person, and he was the initiator of the Detroit school, and he created the TDD discipline in that school. And the way they started to do things is they were creating like the smallest, the basement, and then on top of that they were creating the infrastructure, on top of that they were creating the application. So they started by the small things, and they grew up from there in order to create a complex application. That is bottom-up design. That's why in most cases they were using the actual objects in order to do the tests, instead of creating something fake. But the London school decided to do it otherwise. The London school decided a wild approach at those days, which was, let's start with the big picture and let's ignore the details. And this is a very good advice when you're writing an application that is like a prototype for your customer. Imagine that you are asked to write a prototype in 1-2 weeks, maybe a month, to show your customer if the idea has some meaning for them, if they are willing to invest money in that. Will you spend a lot of time writing code for the database? Most likely not, because that's something that the customer is not going to enjoy, is not going to pay for, is not interested in for a prototype. It's a detail that you will have to solve later. Don't get me wrong. I'm not saying that this shouldn't be done. But what I'm saying is that this is needed in order to do good work. And what it is more relevant is what the user, the customer sees initially, the thing that is the proof of concept that they're going to approve or reject. So what they were doing is, at the highest level, they were defining the code that had to happen there, and the details were faked. And they were using mocks in order to do that. So they were using a top-down design. They were creating like the top-level objects, and the details were faked. So in order to change, to create this fake object, there are a few of them that I want you to know. So at least it rings a bell when you are told of this. The dummy objects come from the crash test dummies. You know what crash test dummies are? Like these objects that look like people that you put in a car and you crash the car to see the effects of the crash in a person without putting a person. So dummies in the jargon of unit testing are those objects that you need to create, but you don't do anything with them. There's no functionality that is required. It's like, I need a parameter here, but this is not the parameter that I'm testing. I need the parameter so I can invoke the method. For this case, I need to put something, but I'm not going to use it. That is done with a dummy. It's like anything that matches the interface that I'm looking for. Stab is a little bit more sophisticated. Is when I want to use some data, I want my object to answer with an expected reply, you have a dummy. And I will try to write an example before we finish if I have time. So it is providing you with expected answers. It's like, I talk to the network, and this is the reply from the network. It's not the reply from the network, it's a fake one, but I'm telling you what I'm getting from the network, so I see if you behave as expected. The spy, do you have here nanny cams? You know what a nanny cam is? A nanny cam is if you have little kids and you want to go out. I mean, like, if you have had little kids, probably you haven't gone out for a while, because it's really hard. You have to stay with your kids. But then it comes that night when your wife or your spouse tells you, hey, let's go out. I cannot be here anymore. So you decide to hire somebody. And you trust that person, but hey, they are your kids. So you better be sure that this person is not doing anything bad to your kids. So you put a bear with a camera inside of the eye that is looking at this person to see how she or he behaves, and you record everything, and when you're at the restaurant, you're connecting and watching the behavior of that person. So that is a spy. A spy is that kind of behavior. It will capture all the behavior, all the interactions, and it will tell you later. It will tell you what has happened. That was exactly the behavior that we implemented with the mega weapon. The mega weapon was listening for us to know when the fire method had been triggered, okay? The mock is similar to the previous ones, but it's a little bit more advanced. So when I have a mock, I already have the verification process, the intelligence for the verification inside of the object. So if I have to check for a few conditions, that is hard-coded, or at least coded, in the mock, so it can verify all the circumstances around the expected behavior. And finally, you have the fakes. The fakes are objects that are meant to simplify tasks that in other way would be complex. Imagine that you want to test sending encrypted messages to another place. If you are testing that, you don't want to encrypt the messages and decrypt them on the other side to figure out that the behavior is being done. What you want to see is that some behavior, some fake crypto is done in order to pass it to the other side. And you want it to be fake because ciphering data to send it to the other side is expensive. And you don't want that CPU cost for each of the tests. You want your test to be as fast as possible. So by faking that behavior, you make your test pass fast. Okay? Clear, the 5 of them? So in order to do that, I recommend to use Mockito here, because Mockito is the tool that does mocking for Android. I mean, all the things that let me show you that part, because I think at least we will have the thing that we would have to do is to add Mockito here. I hope it works, because Mockito. So that would be it. And the only thing that you have to be sure is that this is a unit test implementation. And the other part that I wanted to have here is that you want to use Mockito Kotlin because it makes your code more Kotlin-like, okay? Which is very useful. It's not required, but I recommend you to use it, okay? So let's add Mockito Kotlin. Mockito Kotlin 2. So is this one 2.1? Yeah. So let's add it to unit test. And by doing that, it will be syncing, bringing the data, so on. And the only thing that I have to do in order to run this test properly, instead of defining this, I can say mock mega weapon and create the object. And I can get rid of this, okay? And obviously I have to use the Harman one. And here, instead of asserting like this, what I would say is verify that the weapon, the mock, has invoked the fire method. And in order to do that, okay, it is easier because I don't need the class there. It does everything for me, and if I now use Control-R, it should still pass properly. Okay? So, and we finish with this. Sorry. Up. Those dependencies that you're injecting, the things that you have here that I use as a mock, are dependencies of your code, and you have to inject them properly. You can inject them via the constructor of the object. You can inject them as properties that can be changed, or as an argument of a method, as we did with the mega weapon. The mega weapon was an argument of the method that we were calling, or overwriting a method that provides that value. There are a few other methods, but these are the most typical ones. And alternatively, we can use one of the dependency injection frameworks, which in Android, they are typically Dagger 2, or if you're using Kotlin only, you can use Kotlin or Coin. I think the three of them are very nice. It's fairly complicated. These are easier to understand, but more difficult to test. So, let me get to that part. So you were taking a picture. And let me go with the, ready? 6th phase and depression. And where does depression come from? Depression comes from coverage. As I was saying before, coverage is something that you would like to have, but you don't have initially. So how do you get there? How do you how do you get your project to have enough coverage to be relevant? And, well, the first thing to improve anything is to measure it. I mean, like, you don't know how well or bad you're doing unless you measure how much coverage you have it. And I know that my measuring it is not the easiest thing in the world, and all the things that you use in order to measure coverage, they are somehow faking. I've been told, well, I've seen a few projects that customers were paying per coverage. So they are like hiring agencies or consultant companies who have in their contract saying, you need to have a 90% coverage or 95% coverage, or 25, whatever. So if they match that, they pay for that, otherwise they don't pay for the project. If you ever have that situation, let me tell you that you can write tests that don't do any assertion, but invoke parts of the code, and you will get the coverage that you need. So if you become rich because of that, please share something, send me some money back, and we'll be in Spain expecting your money. If it is not the case, if you want to do this properly, what you can do is assign priorities. I mean, decide what is more important to you. Where are the biggest pain points in your code? What is the part of the code that is always giving you problems, that the bugs show up more frequently? Then you will agree on rules that you will use in your project, so like things saying, hey, you cannot commit any new code unless it has some test. That would be a good rule, okay? The goal here would be to run it. In this case, in Android Studio, you have this run logic test with coverage. And if you do that, you will see that it measures all the methods that have been invoked through a test, saying that they are somehow covered. And it goes line by line saying, this has been invoked, this has been invoked, this has been invoked, and it gives you a percentage based on objects, methods, and lines. Okay? So the percentage is something like this. So you will have like a 100% of classes, 100% of methods, and 100% of lines. But you have some others that are like 57%, 44%, 44% here. So what would be the problem with those? The problem with those is that you have to be aware of what you're measuring. This is a real example, and it's the one that I use for my trainings for architecture. And if you focus on that part, on the domain part, you will see that we have these three parts here, and the one that doesn't comply is the use cases. Oh, why? Let's see with a little bit more of detail. Well, this is fully tested. This is the code I wrote. This code is generated by Dagger. So I don't have to test it. Remember the first rule, you don't test somebody else's code. This is generated by Dagger, so you don't have to test that part, okay? So that is what is missing here. Coverage is completed, but it's showing up as not fully covered because of that, okay? And what happens if you go all the way in and you have too many tests? That is a scenario that everybody would love to have, but it takes some time to run the test. So you refactor and you keep the test that makes sense. I mean, like if sometime you are measuring the same thing in 3 different ways, probably you can write a test that matches all these 3 and in a different way. The second thing you should do is modularize. Modularize, I mean that if you have your domain in a different framework, you can test that independently. So you don't have to pay for the extra time that it takes to run all the other tests. So when you're fixing something in the domain, you only care about the test there. When you're fixing something in the presentation layer, you only care about the presentation layer, your layer. When you're fixing something in the view, you only care about your view. So you're only testing at this level. So each of these layers are completely independent, and they only pay the price for their own tests, okay? And you can also have custom Gradle tasks. The Gradle is what runs underneath the IDE in Android Studio. So you can have tasks that say, oh, I only want to run the tests that go fast. So if you have, usually the view tests are the ones that go a little bit slower. So you can say, mark this test as slow, and the rest of the test will run, but yours will not. So it will improve the test speed by, when I don't need to test anything new from you, I can get rid of your test initially. Well, that was the point I was making about the done slow, okay? And finally, and I will be done with this one, acceptance and hope. That is the latest stage of unit testing. And I hope that by now you have accepted that if we don't have tests, we don't have fun. So I hope that you see that this is pretty easy to be done. I think that it takes some time to learn, but with the basics that we have covered here, you will at least be able to run unit tests in your model. But if you want to improve, there is a long path you can follow. I mean, you can improve your architecture to have more testable code. You can use TDD to have tests in place before we finish, we start writing the code. You can have other types of tests, because let me remind you that the ones that we wrote here are unit tests, and they are only looking at one isolated part of the architecture. So we were talking about the supervillain, and coming back to your question priorly, we are not looking at how the mega weapon behaves. We are just focusing on how the supervillain behaves. Then if we write a mega weapon, we will have to test that one isolatedly. When you want several pieces in order to verify that the behavior of all of them is what you expect, that is called an integration test. And when you're verifying expected behavior from the perspective of the user, something like when the user enters a name, receives a salutation saying, hello, the name of the user that has been entered. And you can see that at the interface level, that will be an acceptation test. And that's something that you want to have. Because let's be honest, I mean, like I don't know about you, but I have never bought an application, a mobile application, because it has a nice architecture, or because it has so many unit tests. I buy a mobile application because it is useful to me and it does what it promises that it will do. That's it. That's it. I couldn't care less about the architecture of the number of unit tests that are running below, okay? And even better, if you want to do this, I usually do that in the training for a week for continuous integration and unit testing. We do CI, which is not trivial, continuous integration, how to merge back all the changes using feature flags, you being able to use A/B testing, and running this in an automated build continuously. That is very useful, but it's a more advanced process than just running these 3 tests. Still, the more you automate, the better, because it reduces the time that it takes to create a new build and to verify when something is going wrong. So the earliest you know about something going wrong, the sooner you can fix it. And that reduces the cost of fixing. So, spasibo. I really appreciate that you spent the 2 hours here with me. I hope that it was worth. Thank you. That means that I know what spasibo means. This is my Twitter handle. If you want to make me any question after the session or send me any message, I will be more than glad. So I will really want to thank to the organizers here for inviting me. And if you have any other questions, I will be more than glad to try to answer them.
Thank you for the presentation. So I want to ask, we in our company using a reactive language. So how to test reactive like Swift or reactive Kotlin? Yes, they're
Okay.
like different a little. Thank you.
Yes and no. I mean, like, one of the characteristics of any reactive language, and I'm not expert on reactive native, but I have done some RX, which is similar, I would say. The important thing here is that you don't couple layers, and then you see the observables of each layer, and you have expectations over those. So I expect some observable to emit a new value if something changes as a result of something. That is a test. I don't know if I'm being too vague here, but for example, you're talking about to your model that is going to talk to the network, and if something is merged, you will emit a new version of the observable. That is what you're testing for. You fake the network, you bring some fake data, and then this new version will be emitted. That is what you're checking. The assertion should be on that observable. Is that more or less clear? Yeah? Any other questions? No? It was really tiring. So thank you again. Спасибо. До свидания.